Hi, this is Charlie Kirkpatrick. This is the third of three videos covering the NIST cybersecurity framework and related readings in Mod 1 of CYSE 200. In this video, we're going to be covering various tools and techniques, some tools and techniques anyway, that you can use within your organization to combat cybersecurity threats. There's a lot of things that you can do, but in this video, we're going to keep it short. And we're going to cover just some of the basics that every company should be aware of, and you as a cybersecurity professional certainly need to be aware of. These threats all address and are covered under the backdrop of the information security triad. This is a fundamental concept in information security, and all centers around the ability to keep confidentiality, integrity, and availability of your information. And by confidentiality, we mean the only people that should have access to data are those that need to have access to that data, and others should not have access to that data. That's confidentiality. Only those that need to know the data. The second part of the triad is integrity. Under this principle, this means that you keep the basic integrity of the information. That is, it's unaltered, it's accurate, and it represents what it was intended to represent. It's unchanged, unaltered, and you have confidence in the fact that both of those are actually true. The third leg of the triad is availability. And what this simply means is that information and related data needs to be available when it's needed. So the systems and the data behind those systems are to be made available to those that are authorized to use it when they need it, and that is within a timely fashion. So that's the CIA triad as it relates to information security. Tools for information security. So I am sure that most, if not all of us, have encountered this scene at any airport that you go into. This is the TSA checkpoint at every airport in America anyway. And so the question that I want you to ask is, what is required of you to gain access beyond this point? So there's really two things that are required. First of all, you need to have some type of identification. That's usually a passport or a driver's license, something related to that. But then you also have to have a second document with you, and that is the boarding pass. Okay, so there's two pieces of information that you need to provide to the TSA authorities before you gain access to the airline. Your identification, which identifies who you are, and then some form of authentication that indicates that you have the right, the authorization to be there. And in this case, it's a boarding pass. So you have to present those two things to gain access to your flight, right? Well, in the cybersecurity world, those two principles certainly apply. Identification is asserting your identity to the system. You're given it your identification, your driver's license, so to speak. Authentication is confirming some other piece of information that confirms your identification. That is, that you are who in fact you say you are. Now, the way to think about this, if you log into nearly any system, you provide two pieces of data. You provide a username and you provide a password. That username, or user ID as the case may be, is used to identify you. Okay, so that's analogous to your driver's license. The password is some other piece of information that you know, that you should only know, and similar to the boarding pass you should be in possession of. That password is used to authenticate you to a particular system. Now, once you hit enter on the web page or on your phone or whatever the case may be, that creates a transaction that goes to an access control system. Now, one of the most popular access control systems that you'll find in most businesses today is from Microsoft. It's called Active Directory. We could spend an entire semester talking about Active Directory. I'm sure you'll get this in some other classes. So the access control system takes your user ID and your password, and it looks you up on an access list within a database, and it pulls out a user profile for you that identifies who you are, has contact information, but most importantly, it provides access levels to what you are authorized to use within a system. That is essentially identification and authorization. Now, you've probably heard the term two-factor authentication. What two-factor authentication is that is a concept whereas you provide something that you know, and in this case it's your user ID and password, but combine that with something that you have, that you are in possession of. So the way two-factor authentication typically works is when you provide your user ID and password to the access control system, the access control system identifies you and then sends you a notice to provide some other kind of proof, usually in the form of some type of a code that is sent to typically your cell phone. So the system will send a notice to your cell phone that says, here is the secret code that you need to type in addition to your user ID and password to gain access into the system. So what this prevents is from someone from stealing your user ID and password and being able to log into the system, because unless they had possession of your phone as well, they wouldn't be able to do that. So two-factor authentication, first factor, something you know. Second factor, something that you have or something that's in your possession. Here at ODU, we have a rather elegant two-factor authentication system called Duo here that's required of all students at ODU now, and starting in the spring of 2019. So if you're watching this video and it's 2019, whether you know it or not, you're doing this under two-factor authentication. And you probably will know it because you'll need to download the Duo app to be able to do that. Second thing I want you to be aware of is access control. Access control is a methodology that is used by system administrators to determine and grant the right accesses, the right level of accesses, and by that I mean the ability to read files, to be able to write to databases or to directories, to add records, to delete records, things of that nature. Those are rights and rights that you would have within any given system. Access control essentially maps you as a user to a particular role within the system, and that role is given various access controls. So if you have the role of an editor, let's say, you would have the ability to read and write to a particular file system or to a database. If you were just in the role of reader, you could read records within that file system or records within that database, but you could not write or add records or delete records from that system. The key behind roles is that it allows an organization to set up a variety of roles, a limited number of roles within the organization, and then assign those roles to individuals, such that an individual who is granted a certain role has the same rights as everyone else associated with that particular role. And what this does from an organizational standpoint and an operational standpoint is it simplifies security, in that when you come into an organization, you will be in a particular role, and within that role, you will be granted certain rights and privileges. Therefore, the administrators, the security administrators, do not have to manage security at an individual level. Instead, it's done at a role level, And everyone that has that particular role has those similar, those same rights and privileges within the system. And in the world of technology, believe me, if you can simplify things, you need to simplify things. And this is a good technique for simplifying access control to your systems. Public key encryption is another really important concept that I want you to be aware of. In public key encryption, the way this works is, and this is typically the way most transactions that you are conducted over the internet when you're purchasing something on the internet, say from Amazon or any other online retailer, you go through what's called public key encryption. The notion behind public key encryption is that there are two keys associated with a given organization. One key is a private key. The private key is kept secret by the organization. In this case, let's just say it's Amazon. Okay, so they have a private key that is used to decrypt any messages coming into their organization. On the user side of the equation, there is a public key. A public key is available to anyone, and the public key encrypts the transaction coming from the users through the internet to the receiver, in this case the Amazon or any other retailer. So if you're going from left to right, the user, you or I, would log on to a retail site, and if we want to, when we want to conduct a transaction, that provider, that organization provides to you a public key. Now this is all behind the scenes, it's handled at the browser level, you don't see any of this, but as you are typing in your order, that order is encrypted at your desktop or your phone, whatever the case may be. It is sent through the internet in an encrypted fashion, and only when it reaches the receiver can it be decrypted by the private key that that receiver has. Okay, so what this means is that if by chance that message is intercepted somewhere between you and the retailer, well, it may be able to be intercepted, but it will not be able to be decrypted because whoever intercepts that does not have the private key. The only organization that has the private key is the organization that owns that private key. So public key encryption is sometimes called public-private key encryption, is an important concept to understand in cybersecurity, particularly when it comes to online transactions. The next thing, pretty simple, backups. You need to assume that there are going to be problems related to information security or availability or the integrity of your data. And one of the most common things that you can do is to back up your disks to backup disks, and then eventually to tape which are stored offline. Now these backups can be entire backups of your system, they can be incremental. Typically they are a combination of whole backups once a week or so, followed by incremental backups every other day of the week, and then the following week perhaps a new full backup is done. But those certain backups will be kept online for ready access. Then after some period of time, that data is stored offline, sometimes in the form of tape, sometimes in the form of additional disks, but in an area that isn't as available as an online backup would be. So backups is a common sense and very common way of safeguarding against cybersecurity related issues. Another concept is that of firewalls. Firewalls are hardware, software, or hardware and software based mechanisms that lie between your internal organization's systems, represented here on the left by the local area network, and the internet in general or other wide area networks. It's a security mechanism that stands between your systems and the broader internet. Insofar as firewalls are concerned, you'll have more exposure to firewalls in this class as well as other classes here at ODU. You cannot forget physical security. It's important to have mechanized locked doors in place, security cameras. Equipment should be properly secured either behind locked doors or even behind locked doors and with the appropriate cables, things of that nature that secure, that literally physically secure tables and computers, things of that nature to walls and such. Environmental monitoring is very important in cybersecurity. Understanding the temperature of your data center, humidity levels within your data center is very important to guarantee or to ensure proper operability of your systems. And you cannot forget employee training. And so often training gets left at on the cutting room floor, so to speak, where we assume that our employees don't need to be trained in the basics of, in this case, cybersecurity or physical security, but they do. And there are clear correlations between employee education and your ability to safeguard yourself against cybersecurity attacks. So don't forget employee training. The last thing I want to talk about in this session is this so-called onion model that is described in the Omerman book, Staying Ahead of the Cybersecurity Game, What Matters Now. And the notion behind the onion model is that it's simply not good enough to just have perimeter security such as firewalls in place. The notion here is that your entire technology stack needs to be protected such that you have to assume that intruders are going to get beyond the perimeter, and they must be trapped and secured once that occurs. That is, they may be able to go north-south into your systems, but you want to put in proper security procedures such that once they're past firewalls, for instance, they can't go, as we refer to, east-west. They can't go any further within your systems. Now, some techniques for doing that is whitelisting at every single level. That is, your default, instead of having everything open to everything, should be that there is no activity and that only the activity that should be permitted within that particular system is permitted. Okay, so default to no, in other words, that's what whitelisting means. Another notion is context-sensitive authorization models. Understanding who should be in what systems, from what location, and when. Once you apply context-sensitive authorization models to your systems, it improves the level of security. Just from a standpoint of, as an example, if there's no reason for anyone outside of the United States to have access to a particular system of yours, then you need to be aware of that and then prevent users from logging on from remote locations. Now, there may be lots of exceptions to that you have to handle from a business standpoint, but the whole notion here is, unless there's a reason to make your systems available 24 hours a day, 7 days a week, to anyone from anywhere in the world, then don't do it. Tighten your systems down to the point where that's not an option. The last notion with the cross-layered model, or the onion model, is personalized security. So based on past behavior, if I'm logging into a series of systems and let's say I've been working at a company for 10 years and I log on to X number of systems each day, and then out of the blue, for some reason, I'm logging into some system that I've never had access to and really shouldn't have access to. Understanding that that is a new event, that is an anomaly, is important from a cybersecurity standpoint. It's another way to help us determine odd behaviors, unexpected behaviors, and perhaps malicious behaviors within our systems. So there you have our wrap-up of this section of Mod 1 reading, Introduction to System Security from Bourgeois and Company. And in this, we have covered the CIA Triad, that you need to be aware of, as well as some of the safeguards associated with most organizations, safeguards that you'll want to be aware of in a cybersecurity world. And then we finished up with this notion of the onion model. I hope you found this to be enjoyable, and I'll see you soon. Thank you.